why do the procedures of this section work? Well, hypothesis tests with N1 times the point estimate of population 1 is greater than or equal to 5, and N1 times the complement of the point estimate 1 is greater than or equal to 5. The distribution of the point estimate 1 can be approximated by a normal distribution with a mean of population proportion 1, standard deviation of the square root of the population proportion 1 times its complement divided by the sample size of 1, and the variance, which is without the square root symbol. This also applies to the second sample. The distributions of the point estimate of 1 and point estimate 2 are each approximated by a normal distribution. So the difference of point estimate 1 minus point estimate 2 will also be approximated by a normal distribution with a mean of population proportion 1 minus population proportion 2 and variance. So here we have the variance of the point estimate of population 1 plus the variance of point estimate population 2, which is equal to population proportion 1 times its complement over N1 plus population proportion 2 times its complement over N2. Now the variance of the differences between two independent random variables is the sum of their individual variances. So the preceding variance leads to the following. We have the variance, which is equal to the square root of the sample pool proportion times its complement over N1 plus again the pooled sample proportion times its complement over N2. Now we know that the distribution of the point estimate 1 minus point estimate 2 is approximately normal. So with the mean of population proportion 1 minus population proportion 2 and standard deviation as shown above, so the z-test statistic has the form given in the key elements box near the beginning of the section. Now, the confidence interval, when constructing a confidence interval estimate of the difference between two proportions, we don't assume that the two proportions are equal, and we estimate the standard deviation as follows. So the standard deviation is going to be the square root of the point estimate 1 times its complement over N1 plus point estimate 2 times its complement over N2. And then in a test statistic, it's the following. Z is equal to the point estimate 1 minus point estimate 2 minus the population proportion 1 minus population proportion 2 times the square root of the point estimate 1 times its complement over N1 plus the point estimate 2 times its complement over N2. And we use the positive and negative values of Z for two tails and then solve for P1 minus P2. The results are the limits of the confidence interval given earlier.